So you should see on my screen probability distributions. And that's what 4.1 is about. So we will jump in and I'm going to kind of interrupt us a little bit through the PowerPoint and do some problems on the system. That way you'll know what you're coming across when you get to the homework. So we start this conversation with random variables, and they represent a numerical value associated with each outcome of a probability distribution, and they are denoted by X. So X, for example, X could equal the number of sales calls a person makes in one day, or X could equal the hours spent on sales calls in one day. We have two types of random variables. We have a discrete random variable. So it has a finite or countable number of possible outcomes that can be listed. So an example here is X equals the number of sales calls a salesperson makes in one day. Another example might be how many fish did you catch? Um, how many people were at the party? Those are all finite numbers. You're not going to have half of a person. Okay, so think integers. And next we have continuous random variables. They have an uncountable number of possible outcomes represented by an interval on the number line. So an example is hours spent on sales calls in one day. You might have the gallons of gas in your tank. And I say that because you could have like 36, right? Can I write? 36.8 gallons of gas. You could have 36.85 gallons of gas, 36.853 gallons of gas. There's a continuum in between the integers that you can fall in. And you might think about times that uh what's the girl's name who is real fast? Shak Shak Shakara?
Shakari Richardson.
Thank you, Shakari Richardson. So her times when she's running, the times are on a continuum. You could have 5 minutes, 5 seconds, 5 minutes, 3 seconds, 5 minutes, 5.3 seconds. And sometimes it comes down to those little point threes to see who wins the track meet or who wins the race. Anyway, let's determine some on our own. Oh, wow, it gave you the answer already. But here's an example of a discrete random variable and the number of Fortune 500 companies that lost money in the previous year. We can count the number of companies. We're not going to have like half of a company. We're not going to have 0.6 of a company. It's going to be a company or not. Okay. And the next one is a random variable X that is the volume of gasoline in a 21-gallon tank. That is continuous because I think I gave you this example just a few seconds ago. You could have 36.8 gallons of gas, 36.853 gallons of gas. And sometimes we're looking at that gas meter and we're like, okay, when are you gonna stop? When are you gonna stop? Hurry up and fill up so I don't have to spend so much money. But that is on a continuum. Some of the characteristics of a discrete probability distribution. Number one, the probability of each value of the discrete random variable is between 0 and 1. So you can't have negative numbers and you can't have anything that's greater than 1, each value. Number two, the sum of all the probabilities has to equal up to 1. Okay, let's look at some of the questions that we're going to come across here. Remember, all the probabilities are between 0 and 1, and the sum of the probabilities, that's what this little E stands for, summation, the sum of the probabilities is equal to 1. Okay. Let's look at 4.1 question 11. Okay. All right. So determine whether the distribution is a discrete probability distribution. And let's pop this out so we can see it a little. I don't want to open the StatCrunch. I wanted it to show a little bit bigger. Did that work? Nope. Okay. Well, maybe that's as big as we're going to get. Yeah. All right. So what you want to do when you're trying to determine if it's a probability distribution, first of all, what we were talking about earlier is all of these values, when I add them together, they equal up to 1. Also, each of these values has to be between 0 and 1. So when you add up all these values together, what do you get? I see a greater than 1, and I see a 1. Well, one thing I'm looking at is that you've got this 0.5 here, and 0.3 and 0.2, 0.32 and 0.2. That's 0.52 right there, plus 0.5, that's greater than 1. So the answer here is what? A, B, C, or D? Right, no, because the total probability is not equal to 1. All right, next question. What about this one? Is this a probability distribution? I'll give you a few seconds to calculate each of those. One thing I'll point out while you're calculating is that if I click on this double window and I open it up in StatCrunch, something interesting happens. I just discovered this 2 seconds ago. They convert everything to decimal for you. Notice that? So 1/5 is 0.2, 0.04, 0.75. And if you didn't want to add those together yourself, you can go to compute an expression, build, and we're looking for the sum of P of X. And okay, and compute. And so they've added this column here, 1.55, so that's greater than 1. Yeah, I think this is pretty interesting. If you were just using the TI, you would just enter in each one, 1 divided by 5 plus 1 divided by 25 plus 3 divided by 4 plus 1 divided by 20. I'm already committed, plus 1/2, half plus 1 over 100. Still, we get the same answer. Is it B? I clicked on one. I didn't mean to click on one. It won't let me unclick it, but which one is it? I accidentally clicked on the answer and I couldn't, can't unsee it. Yeah, no, because the total probability is not equal to one. It's not B because this is saying that one of the values has is greater than or greater than one or less than zero. Oh, okay. Okay. So that's our homework. Some of the questions you'll come across just for that one, for determining if they are if it's a probability distribution. So we're getting some instructions on what to do on how to build these tables. Now, we'll run through it quickly, but I also just want to show you an example because sometimes it's easier to visualize when you see the example. But the first step, you're going to make a frequency distribution for the possible outcomes, find the sum of the frequencies, find the probability of each possible outcome by dividing its frequency by the sum of the frequencies, and then check that each probability is between 0 and 1 and that the sum is 1. So we're checking in that number 4, we're checking that those two rules hold. Okay, so the first thing, make a frequency distribution for the possible outcomes. We've already done that here. Second one, find the sum of the frequencies. Well, so we would add them all together and we would get 150. The third one, find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. This is on the next page, but just to show you what that step is 24 divided by 150 here, 33 divided by 150, and so on. 42 divided by 150, 30 divided by 150, and 21 divided by 150. Next instruction, we're going to check that each probability is between 0 and 1 and that the sum is 1. So you would add all those together and make sure we know that they're all between 0 and 1 because every numerator is smaller than the denominator. So we know that it's between 0 and 1, but we don't know what was the next one? That the sum, what the sum is. We'd have to add that together. And so here's our table. Here's our values in decimal. 0.16, 0.22, 0.28, 0.20, 0.14. And we add those together and those equal to 1. So yes, this is a valid discrete probability distribution since those two rules hold. Okay. Then we graph it. We use a histogram to graph our frequencies. Well, last week we called this the relative frequency. So this week we're calling it the probabilities, the probability of each outcome, random variable X. Okay, so let's look at your homework and see what you're going to come across with these types of questions. Okay, so here's one, a frequency distribution is shown below, complete parts A and B. Um, again, you're going to take 20, you're going to add all these together, open in StatCrunch, and I'm going to just add them all together here. Then I'm going to show you a different way to go about doing this. Data, compute, build, sum, um, of household. I keep landing outside of the parentheses when I want to be on the inside. compute. So then it gives me this 2606, and that is the total of these households. So what I can do, I can go back and build. I wonder if I can just go back into build from here. What I want to do is take households and divide that, or division symbol, divide that by the sum of households and compute. So here are my probabilities. Notice I go from small to large. And it's not always going to happen like that. Like in our PowerPoint, we had one that kind of went into like this normal curve looking histogram. Uh, but here's that, and you can do it that way. That's one way you could do these. Oops. Now, in StatCrunch, they have something else you could do. You go to Stat, Calculators, Custom, and the values are in televisions, the weights are in households, and then compute. So it gives you, the bars here are skinny, but if you look at, actually, I think our question, this is going to be the second part of this question. Let me show you the completed version here. If you look at the graphs, they match up to this graph of our probability relative frequencies matches up to these little bars. Even though they're small, skinny, you can still kind of see where there's a stair step. And then you describe the shape of the histogram. And we talked about the shape of it last week. Okay. Let's look at question 7. Is it going to be a similar question? I want to work one of these. Question 8. Okay. So here is probabilities. Find the probability of randomly selecting a household that has one or two televisions. What is my strategy here? What am I going to do? I keep clicking on this. I'm trying to get back to my team screen. What do you think I should do if I want to know the probability of randomly selecting a household that has one or two televisions? Yes, the answer was given, add the probabilities under 1 and 2. So 0.18 plus 0.25. So let me pull this up again. 0.18 plus 0.25, 0.43. All right, what about finding the probability of selecting a household that has two or more televisions? Right, it would be the sum of the probabilities under 2 and 3. And what is that number? I got a 0.79. Do we have an agreement with that number? Okay. All right. Find the probability of randomly selecting a household that has between 1 and 3 televisions inclusive. You could use the complement rule here. Right, I've got a 0.97. And the complement rule, the way we would use that is you look at the probability of zero. That's the only one that's not included. So you would do 1 minus 0.03. So it should be, yeah, 0.97. Easy enough. Oh, got another one. Find the probability of randomly selecting a household that has at most two televisions, at most two televisions. And you can use the complement rule here too. What number did you subtract from 1 to get 0.46? Right, 0.54. The only one that's not included is 0.54. So you could do 1 minus 0.54. And so I got a lot of 0.46s. Great, great, great. Let's go back to that question. Oh, it was going to make me do it again. So what I want to do, um, I know there's some people that have, let's go back, was it question 6? We didn't work this one. I know there's some people that have the TI calculator, and you can find the probabilities of these in the TI calculator, and I'm going to show you how to do that. Go. I couldn't move it out of the way. All right. We've got 28, 448. So I'm going to go to list 2, and I'm going to put in those numbers, 28, 448, 720, 1403. And then in my list 3, this is how we do this. This is the part. You're going to go second 2, which puts an L2 into the L3 mark. Then you're going to divide by, and then second stat math sum of what? The sum of L2. So second L2 and enter. So that's how you would get the relative frequencies in a TI 84 calculator. So again, it was second 2 to get list 2. Let me just go clear it and do it again. So second 2 to get list 2, divide by second stat math sum, and then second 2 again to get to L2 and enter. Oh, let me do it again. You have to be in that top part, L2, second. You're really going to know how to do it now since this is the third time I'm doing it. Sum, second 2. There we go. So that's how you do that. So you can do it with your calculator. You can do it with StatCrunch. You can do it with StatCrunch by doing the sum and then building an equation as well. Or you can use the function that we looked at, Stat Calculators Custom. Even though the graph, again, has skinny bars, you can kind of see the pattern. Yes, we can. So in StatCrunch, stat calculators, custom, values are in televisions, weights are in households, and then compute. This gives us the graph. Oh, this gives us the graph. Are you looking for how to do the relative frequencies in StatCrunch? That was the compute, expression, build. And remember, to get the sum, we did sum, and then sum of the households. Okay, and compute. Now, this is the second time I'm doing it, so it's populating again, but there's your 2606. And then I can go back to my build function, and I want households, households. Oh, it won't let me do it. So let me get rid of all of this. So households divided by the sum of households, and then okay, and then compute. And so there it gives me my relative frequencies. Now, this is a different set of data. I was just using the data that we had in here. But yeah, it's totally doable in StatCrunch. Okay. Any questions about that? How we do it in the TI or how we do it in StatCrunch? Okay, you're welcome. So we have the mean of a discrete probability distribution, and that's going to be the sum of the x's times the probability of x. So what we're going to do is take each of these values, the x values, we're going to multiply them by its corresponding probability of x. So what this looks like, try the pen, is 1 times 0.16 plus 2 times 0.22 plus 3 times 0.28. Come down here, plus 4 times 0.20 plus 5 times 0.14. And you'll add those all together, and that gives you the 2.94. Okay. So then the variance of a discrete probability distribution, this is going to be like we did before, where we're building tables. But the variance here is the summation of x minus the mean squared times the probability of x. Now, then the standard deviation is just the square root of that. And that's the difference between the variance and the standard deviation. The standard deviation is the square root of the variance, and that's basically always. So if you just remember that, then you'll be pretty good. So if we wanted to find the variance and standard deviation of this particular set, again, we could do it by hand. And this is what this looks like. So what they did was x minus mu. And what you'll have to do is square this and multiply it times the probability. And here, negative 0.94 squared times 0.22. And I won't do all of these, but you get the point. You're going to square times 0.28. And then you will add all of these together to get the variance. Once you get the variance, the standard deviation is just the square root symbol away. Okay. Let me see if I had an example question for this one. Question 14, question 13. All right, so they're asking for the mean of this probability distribution. Now, I'm going to open this in StatCrunch. Here's where we're going to do the same thing we did before, but we're going to be looking in a different place for the information. So Stat Calculator's custom, values in X, probabilities, weights in P of X, and then compute. Notice, if you didn't notice before, we get the graph like I was showing you before, but we also get the mean and the standard deviation. So here's what we do with this. So the mean, it says round to one decimal place, 0.6. And then they're asking for the variance. Here's what I need to do. I need to take this variance and do I have my calculator? Let me pull up the other calculator. All right, I had copied in this number. This is the standard deviation. So in order to get from here to the variance, I have to square this because this is the variance, the square root of the variance. So I'm going to just square that number, and it says round to one decimal place. This is the variance, 0.88. So this would be 0.9. And then find the standard deviation. We already had that in our StatCrunch screen. It's 0.9 also. So it's okay if they're the same. Then we interpret the results. What do you think? A, B, C, or D? I'll give you a chance to read those options. And our mean was 0.6, just in case. Okay. Lots of A's. Let's go for it. And fantastic. Fantastic. Okay. So let's try it with question 14. Again, open in StatCrunch. Let's see if you remember. What's my next step? Where do I go from here to get the mean and standard deviation of this? Stat. Yeah. Calculators. Then what? Custom. Custom. Yep. The values are in defects, weights are in probability, and compute. And we've got our information there. Remember, the standard deviation is the square root of the variance. So when it gives you the standard deviation, you have to square it, meaning multiply it by itself. in order to get the variance. Okay. Does that make sense to us? Okay. Got 8 minutes. Last thing we'll cover is expected value, and it's kind of the same premise and well, it is the same of finding the mean, but how do we apply this? So let's look at question 16. Okay, we've got an American roulette game. If a player bets $8 on a number and wins, then the player keeps $8 and receives an additional 280. Otherwise, the player is awarded nothing and the casino takes the player's $8. Find the expected value to the player for one play of the game. If X is the gain to a player in a game of chance, then the expected value, E of X, is usually negative. This value gives the average amount per game the player can expect to lose. Now, we need X and we need the probability of X. So we, if we win the 280, this thing, X 280, and then P of X, that will be 1 out of 38, my probability of X, 1 out of 38. And then we take the $8, subtract $8, right? If we lose that $8, and that probability is 37 out of 38, because we're only going to have one option out of the 38 that's a winner. So what we're going to do is add these together, multiply those together, and then add them up, and that's the expected value. So let's go, oops, 280 times 1 out of 38 plus -8 times 37 out of 38 and enter. So notice our expected value is negative 0.42. So in this case, in our problem, the expected value is going to be negative 0.42.
I don't have a question, but I think I have found an easier way to do the mean with the calculator.
Okay, what'd you find?
um, so like if you go to stat and then go to edit and then do like, the list L1 and L2.
Uh-huh.
After you do that, then um you go to stat again, then go over to calculations or calc, and then go to
Mm-hmm.
1. And then when it says list, you do L1. And then when it says frequent list, go to L2 and then calculate, and then it'll all come up. Oh, sorry. Oh, yeah, yeah, I guess like that. Yeah.
Is that right?
And then I think so. Mine looks different, but it could be that. And then you go to enter. Yeah. And then the X with the line on top, that's the mean. And then the
Mm-hmm.
OX, like you said, is that the standard deviation?
Standard deviation. Oh, let's do that again. Okay, edit, and then stat, calculate, one variable statistics, and the second L1, comma, second L2, and enter. Yes, nice.
Yay.
Yes, I'm excited. I need to write this down. I need to write this down so I don't forget. Started here. Okay. So we're talking about the standard normal distribution. So let's start with the properties of the normal distribution. The mean, median, mode are equal. It's bell-shaped and symmetric around the mean, and this is the mean. Remember the mean mu. The total area under the normal curve is equal to 1. It gets very, very close to this horizontal line, but it never touches it. Very, very close to the horizontal line, but never touches it. Okay. We have on the normal curve what's called inflection points. That's where you go from concave down to concave up. Basically, you're switching from like this and you're going to that. So concave down to concave up. That's an inflection point. And that happens one standard deviation away from the mean. Okay. So here are a couple of graphs of normal curves. It can have any mean and any positive standard deviation. The mean gives us the location of the line of symmetry, and the standard deviation describes how spread out the data is. So notice on this first graph, A, we're pretty spread out. The inflection points are at the first standard deviation, 1.5 away from 3.5, so it's at 2. And then over here, I'm 1.5 away from 3.5, so I'm landing at 5. And notice that's my inflection point where I go from concave down to concave up. And then we see when my standard deviation gets smaller, or smaller, my normal curve gets skinnier. And its inflection points are here at 0.7 away from 3.5. So uh, that's that graph. And now see, my graph has shifted over to the left to 1.5 being the mean, but my standard deviation, how spread out my data is the same as graph B is 0.7. But we're emanating out from 1.5 as opposed to emanating out from 3.5. Let me make sure there's not a question we need to answer for that. Okay. Okay. All right. Which curve has the greater mean? Well, where's the mean at? So here's where the mean is, right? Right down the middle of the curve. So we know that curve A would have the greater mean. And then which curve has the greater standard deviation? Well, that's curve B. Because it's more spread out. That means the standard deviation is greater. Interpreting graphs. Now, the scaled test scores for New York State grade 8 mathematics test are normally distributed. The normal curve shown below represents the distribution. Estimate the standard deviation. So what we can do in that case is locate the inflection points. Remember, we said that at the inflection points, that's where the first standard deviation is. So that means we're measuring from the first inflection point to the mean. We're trying to find that distance. And we found that to be about 35 in each direction. Away from the mean of 675. So the inflection points tell us where the first standard deviation is, or that helps us find the standard deviation. All right. Any x value can be transformed into a z-score by using the formula given below. And this formula is going to be very important to you. Z equals the value minus the mean divided by the standard deviation. The value minus the mean divided by the standard deviation. A standard normal distribution will have a mean of 0 and a standard deviation of 1. So what we're trying to do when we're transforming into z-scores is we're trying to get back to that 0 and 1, 0 mean, 1 standard deviation. That's what we're trying to do. And we do this so that we can compare values. And let's look here. This is just a graphic of what I just said. So let's say you have a mean mu, it may not be 0, but when we transform to a z-score, we're moving that mean back to 0. And then we can use what's called the standard normal table to find the cumulative area under the standard normal curve. Okay. So at z equals negative 3.49, this area basically is close to 0 because it's more than 3 standard deviations away. And we learned last week that if you're 2 or more standard deviations away, you're considered to be unusual. Well, we're 3, so of course we're close to 0. The cumulative area increases as the z-scores increase. So as you move to the right, the area increases. Who knows what the area is right here of this part? If this is close to 0 and this is close to 1, what's in the middle? What do you think? We got a 0.5. So 0.5s. Great. You're right. It is 0.5. It is 0.5. Yep. So z equals 0 is 0.5. And the area close to 1 would be 3.49. Now, finding the cumulative area in the table using the standard normal table. So find 1.1 in the left-hand column for 1.15. That's what we're looking for. If we're looking for a z-score of 1.15, we would look for 1.1 on the left-hand side. And at the top, we're looking for 0.05 because 1.1 plus 0.05 is 1.15. That area is going to be 0.8749. So basically where they come together, that's the area. Okay. You can accomplish the same thing in StatCrunch. Let's go back to StatCrunch. Where did my StatCrunch go? We're in 5.1. So I look at 5.1. I'm just pulling this up so I can go to a question and pull up StatCrunch. Okay. So we are looking for the shaded area well, let me just pull this up and show you 1.15. It would be stat, calculators, and normal, and your z-score is 1.15, and you hit enter, and you get this area, that area to the left. Real quick, while we're in here, if I wanted the area to the right of this z-score, I would just flip my inequality to the other side, and that's the area to the right. You could also have found that by going 1 minus 0.8749 to get the 1.1250. Okay, so stat, calculators, normal for StatCrunch. And this is looking for 1.84. So on the table, you go to 1.8 and then 0.04. Okay. Now, we just talked about finding areas under the curve. Of course, your table is going to report values to the left of the z-score. It's going to report values to the left of the z-score. So if I want values to the right of the z-score, I need to subtract the pen to work here. I need to subtract from 1. So if to the left of the z-score 1.23 is 0.8907, then to the right of that, this is going to be 1 minus 0.8907. And that's how we read a table. StatCrunch steps again. What was that? 1.23. So 1.23. Oops. I get 0.8907. And then 1 minus 0.907 is going to be 0.1093. All right. And this is just what I was explaining earlier. To find areas to the right of Z, you have to do 1 minus the area that's given in the table. But in StatCrunch, you can now the calculator, I believe, let me pull that back up. TI-84. Second, VARs, then normal CDF, then lower bound and upper bound. Now, if you're just asking for, like, let me go to the previous screen, like from the all the way to the left to the right, you're going to put in just a big number. So like negative 10,000. That's as your lower bound. And your upper bound is 1.23. And then your mean is 0. Your standard deviation is 1, and enter, and you should get the 0.8907. Conversely, if you're looking for the area to the right of that, I probably should have just done this again. Second VARs, normal CDF, 1.23, to the right, 10,000, 123, comma, the mean is 0, standard deviation is 1, enter. You get 0.1093. If you have, while I'm here, a situation where you have an upper bound and a lower bound, you're just going to put that upper bound and lower bound into the calculator. So second VARs, normal CDF, and the lower bound is negative 0.75. Upper bound is 1.23. Mean is 0. Standard deviation is 1. Enter. 0.6641. Okay. Of course, you could do it in StatCrunch too. To find the between values, you just click on between and you enter in negative 0.75 and 1.23. If you need to adjust your mean and standard deviation, you can right here. Wanted that little pop-up box to go away. So up here, you've got standard and you've got between. With the normal CDF function on the TI-84, you've got lower bound and upper bound. Okay. Oh, in the table though, you would find the area of 1.23, which is 0.8907. Then you would find the area of negative 0.75, which is this 0.226, and then you would subtract them from each other. And that would get you the area in between. So you can find it with the table as well. Whatever mode of technology or hand calculation you would like to use, please do so. All right, let's look at question 5. Oh, we're here. Question 5. So it says, find the area of the shaded region under the standard normal curve. Click here to view the standard normal table. So here's our table, and it's 1.34. So I click the table. I'm looking for 1.3, and 4 is 0.9099. What do I need to do to this 0.9099 in order to get the area to the right of 1.34? What should I do? Okay, so 1 minus 0.9099. Subtract. You're going to subtract that number from 1. And then, again, with the calculator, so I'm just going to go back and pull this one because I'm area to the right. And I'm going to put in 1.34. And I get 0.090122. Round to 4 decimal places, 0.10, oops, 0.901. All right. So in this one, it's actually telling you to use technology. So I'll give you a few minutes to use technology. You can use either your TI-84 calculator or you can pull up your StatCrunch. And figure out what the area of this shaded region is. I'll give you a few minutes. I'm set my timer on the watch. So remember, you can go to StatCrunch from right within the problem. So if you went into the homework and you pulled up your homework, you could just go into the StatCrunch from any problem that's there. So we'll look at the StatCrunch solution, then we'll look at the um, TI-84. So we've got stat calculators normal. We're between this time, and we're going to be between negative 2.36 and 0. So, hey, in the calculator, let's see if we're still up here. I put, when I did this the first time, I put a uh, zero point 0.5 in here instead of 0 because I knew 0.5 was the area in the middle. So we hit enter here, oh, there. Okay, 0.4909. That is correct. Let's check on another one. Ooh, Stumper. You want to find the area to the left of negative 1.57 and the area to the right of z equals 2.38. Hmm. So just in case you want to see what that looks like, you want to find the area on the curve to the left of negative 1.3, 1.57. So you want to find this area and you want to find the area to the right of 2.38. So it's kind of a multi-step problem because you got to find this area and then you got to find that area. So I'll give you a few minutes. Or I'll put 3 minutes on the clock again. This is a bit of a stumper. Maybe I should give you 5 minutes. Okay. There is an alternate way you could do this as well. You could find the two areas and add them together, or you could do 1 minus the between area. Let's see if we come up with the same answer. So I go between, and we said the answer is 0.0669 between negative 1.57 and 2.38. That gives me 0.93313. So what I can do is I can subtract that from 1. Oh, let me use my other calculator. So 1 minus that number, and we get the same thing, 0.669. So you can subtract away the between area, or you can find the two areas and add them together. Either way works. Okie dokie. I think the section was shorter. Okay. We found the area. We know how to find the area to the right. We know how to find the area between. And we are done with section 5.1. That is 5.1 in a nutshell. So let's look at 5.2. All right. So 5.3 gets into actually finding the z-score, which we had discussed a little bit earlier. When we're finding the area, remember the mean was 0 and the standard deviation was 1. Now our mean is going to be a certain number and the standard deviation is going to be a certain number. So let's see what we're going to do is we can convert that to a z-score and find out that if I'm looking for x is less than 600, I'm actually going one standard deviation to the right of the mean. And that area is the same as the probability of x is less than 600. So they didn't give us the area of that one. All right. A survey indicates that people use their cellular phones an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cellular phone user is selected at random. Find the probability that the user will use their current phone for less than 1 year before buying a new one. Assume that the variable x is normally distributed. So we set this up. What we're looking for, we find the z-score. The z-score for 1 is x minus the mean divided by the standard deviation. So 1 minus 1.5 divided by 0.25, which equals -2. And so we get from the standard normal table, this is 0.0228, but in StatCrunch, did I close StatCrunch? In StatCrunch, we can now fill in the mean that they gave us. They gave us 1.5 and then 0.25. And then I want to find the probability that x is less than 1. So I hit enter, and there it is. In our handy dandy calculator, I just want this normal CDF function. The lower bound is that -10,000, right? Because you're looking for everything to the left of 1. The upper bound is 1. Oops. Comma. My mean is 1.5. My standard deviation is 0.25. And I get the same 0.228, 0.0228. All right. So now a survey indicates that for each trip to the supermarket, the shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store is normally distributed and is represented by the variable x. The shopper enters the store. Find the probability that the shopper will be in the store for between 24 and 54 minutes. So we're looking for a between, right? Remember, we're looking for a between. So 24 and 54 minutes. My mean is going to be 45 minutes. The standard deviation is 12. Now, this is not drawn to scale, but we can apply the same premise. Now, you can find the z-score and use the table, and that's why the z-score is useful, or you can use technology. So, in StatCrunch, you go between and you just fill in the information you have. 45 minutes, 12 minutes, and then from 24 to 54, and compute. Same thing with the calculator. I think this one is easier on the TI-84 because you already fill in a lower bound and upper bound. So lower is 24, upper is 54. Your mean is 45, comma, 12, enter. 0.7333. So basically, what they're trying to tell you is that um, you don't have to have a mean of 0 and 1, but you can always get back to a mean of 0 and 1 if you should so choose. And so they want us now to find the probability that the shopper will be in the store more than 39 minutes. Well, we could go Stat Crunch, standard, change this around, 4512, more than how many minutes? 39. More than 39 minutes. That's 0.691. And calculator, I want, oops, always trying to do stuff on with my mouse and I can't do it with my mouse. And it was greater than 39 minutes. And we were at 45 and 12. Oh, it's like 0. Let me back over here and get this out of here. 2.6914. Okay. Yeah, my team's window. Is this part making sense here? How we're using a different mean and standard deviation, but we're coming to the same conclusions? Is that a give me? Yeah. Yes. Thumbs up. All goof. Okay. Okay. Got a few people in there. Didn't do that. So they challenge you too. It says if 200 shoppers enter the store, how many shoppers would you expect to be in the store more than 39 minutes? Well, I'm going to multiply 200 by the probability that someone would be in the store for 39 minutes. So in this case, that would be 200 times 0.6915, and that equals 138 shoppers. Remember, shoppers is discrete, so we don't have decimal values of shoppers. We don't have 0.3 of a person. We just have people. I actually thought that I was in 5.3, but I wasn't. So we need to go backwards now and find actual values um, of z-scores given the area. So then we're going to transform uh, from a z-score to an x value, and then how to find a specific data value of a normal distribution given the probability. Okay. Okay. So find the z-score that corresponds to a cumulative area of 0.3632. What is a z-score? Doesn't tell us. How do we find it? Well, this is where we're going to do a backward lookup. So let's look in the table. So notice this time I'm not looking on the left and the top. I'm looking at inside the table. So my area was 0.3632, and inside the table that corresponds to negative 0.35. Wow. Excuse my dog. Oh, this real quick. Okay. um, inside the table. Now, two ways to do this in StatCrunch and in the calculator. So let's go over those. In StatCrunch, you're going to be in the same window that we were in previously. So this is standard, mean is 0, standard deviation is 1. I'm going to put a little bit, and the area we said was 0.3632. So I'm going to put it in the area box in the bottom right and then enter. And then it gives me what the uh, z-score is. Okay, so that is how you do it in StatCrunch. Now let me make sure my calculator is up. And we are second vars. And this time we're inverse norm, or option 3. We're going to put in the area 0.3632, then the mean 0, and then the standard deviation of 1, and hit enter. Oh, I put in the wrong area. It's 0.36632. Okay. So we have two different ways of, well, three actually. We've got the table, we've got StatCrunch, and we have the TI-84, just depending on which mode of technology you are using. Okay. Find the z-score that has 10.75% of the distribution's area to its right. Okay. Now, in the table, we're going to do 1 minus 0.1075 in order to find that where that z-score is, because the table reads from left to right. So we're looking for 0.8925. And again, in the calculator, the TI, I think you have to do this 1 minus as well. In your calculator, if you're using the calculator for now, you're going to just put in the area 1 minus the area to the right. Okay. Now, find the z-score that corresponds to P5. P5 means the percentile, the 5th percentile. And so in percentage, this is going to be 5%. This is going to be 5%. Of course, in decimal, that is 0.05. So when you see this P, that means percentile, the fifth percentile. Okay. And then we can just put it in the calculator. Put the area of 0.05 in the calculator or StatCrunch. So, and you get negative 1.645. All right. And then we can transform a z-score into an x score. And how do we do that? We're going to use this formula. X equals the mean plus z times the standard deviation. And remember, we came from this, z equals x minus mu times divided by the standard deviation. So all they did was multiply the standard deviation by both sides. And then they added the mean to both sides. So if you don't remember the formula outright, you can actually derive it really quickly by working backwards to solve for x. Okay. So we had a veterinarian with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights x corresponding to z-scores of 1.96, negative 0.44, and 0. So we just plug into the formula 1.96, negative 0.44, and 1.96. And we notice 12.92 pounds is above the mean, 8.12 pounds is below the mean, and 9 pounds is equal to the mean because we're at 0. So that's really just a formula that you're going to have to apply there. All right, scores for the California Peace Officer Standards and Training Test are normally distributed. The mean of 50, standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? Okay, so here we go and examine the top 10% is any score above the 90th percentile. So we're going to find the z-score that corresponds to a cumulative area of 0.9. What's the z-score that, and they said 50 and 10. Uh-oh, I gave you the answer. Well, if you had put in here 0 and 1 and 0.9, you would get the z-score of 1.28. But if you put in the 50, the 10, and 0.9, you get the actual value itself, 62.8. So that's nice. Same thing with the calculator. We go, let me just do it again. Second vars, inverse norm, area of 0.9, comma, 50, comma, 10 as this mean and standard deviation, and it gives you that value, 62.81. Okay. All right. That is 5.3.